Hi there, nice to meet you. I'm Waji, a student from the Aerospace Engineering Department, where innovation takes flight. Curious about what our department is like? Today the weather is good, so follow me and I'll show you around. So this is the lobby of our department. Aerospace Engineering was created from a dream to fly and reach the stars. For example, here you can find sneak peek on the milestone that we reached as a field. From the propeller aircraft, helicopters, to fighter jets, and even satellites. So, shall we go to the next location? Let's head to Professor Hugh Sanguin's lab and see what research is happening there. I was an intern in this lab and I can assure you it's amazing. Here we are at Spacecraft Prototyping Lab. Here we develop a laser communication satellite and currently research satellite attitude control and deep space navigation using Star Tracker bundle. When a satellite does its job, it might need to rotate to look at the sun for recharging or to communicate with the ground. This is called attitude control. First, let me show you a one-axis attitude control model. If you shine a light with a flash, the sensor recognizes it and it turns to the solar panel. It's designed to adjust even if you touch it with your finger, simulating atmospheric resistance. If the Earth blocks the sun, how do we know the spacecraft position? That's where the star sensor comes in. Star trackers take pictures of stars and compare them with a celestial catalog to determine the spacecraft's attitude. We're also researching how star sensors can determine the spacecraft's speed by analyzing how quickly stars' position change, like raindrops on a moving car's window. We're experimenting with star trackers and astronomical dome, using Earth's movement around the sun as a test. If it were at night, I could show you the equipment in action, but it's daytime now. Hey, how's it going? Where are we? This is Professor Jongyo Lee's lab. Here we are researching a robotics puppy and linear puppy. Puppy generates ultrasonic waves on the surface of the specimen by applying pulse echo ultrasonic waves to the specimen. Then measures and analyzes the ultrasonic signal through LDV sensing laser to perform non-destructive testing. It is a non-destructive inspection system that visualizes features and defects inside the specimen through ultrasonic signal post-processing. This is where the A11 Lecture is taking place. This class is the signature lecture of our department, and today is the final demonstration day. This is going to be exciting. Do you want to know what it's all about? Follow me. A11 course consists of a series of lectures and an LTA designer project. First, the fundamental aeronautical engineering concept and approaches will be introduced to the newcomers of AE through lectures. At the same time, the students are asked to conduct the LTA design project, through which they will learn how to link their knowledge in the textbook to the real engineering world. Hello, Professor. How are you today?
Oh, I'm fine. So,
we're here today to ask you about the AE11 lecture. What's so special about it?
Okay, so as you can see here, so by doing the LTA design project, students will learn the basic principle of the airplane. So one of the biggest attraction of this course is it is very funny and enjoyable, and also highly rewarding. Students will never forget about the sense of gratification they get when their LTA takes flight for the first time. So one more thing is this course will allow the students to become very close to each other.
So how was it? Exciting, isn't it? With so much more options, our department provides the perfect launchpad for your aspirations. So why don't you join us and become a part of the future of aerospace engineering? It's even more fun when you're here. See ya!